Welcome to Sketching Regions. So we're going to start with an example straight away. We're going to find the shaded region of y less than or equal to x plus 2 and y greater than or equal to 4 minus x. So the first thing we're going to look at is, well, how would we actually sketch this equation? So rather than deal with it as an inequality, we're just going to make it an equality or an equation. So y equals x plus 2 is a straight line. When x is 0, y equals 2, and when y equals 0, x equals minus 2, and that will allow us to sketch the straight line. To find which side of the line is the shaded region, we substitute into the original inequality, that's y less than or equal to x plus 2, in this case, a point that doesn't lie on the line. So normally we choose the easiest numbers, which is 0, 0. If it's true, when we do the inequality, then the shade includes the point. So let's sub it into y less than or equal to x plus 2. So y is 0 when x is 0. So 0 is less than or equal to 0 plus 2. 0 is less than or equal to 2. That is true. So there's our line, and the side that we shade includes 0, 0. Let's look at the other one. So y equals 4 minus x is also a straight line. When x is 0, y is 4, and when y is 0, x is 4. So that means we can actually sketch our line. Y greater than or equal to 4 minus x, we once again sub in 0, 0. So 0 is greater than or equal to 4 minus 0. 0 greater than or equal to 4, which is false. So therefore, when we shade for this one, we don't include 0, 0. And you can see 0, 0 is not on the shaded side. So it's above the line in this case. We can also find the point of intersection using simultaneous equations. Not always necessary, but you could be asked to. So in solving them simultaneously, since they both start with y equals, we can just make the two equal each other, the two equations. So x plus 2 equals 4 minus x. Add the x across to get 2x plus 2 equals 4, minus the 2. Across, get you 2x equals 2. Divide by the 2, so x is 1. And if I substitute that back into either of the original equations, I get y is 3. And we can see where the two lines overlap, the shaded regions overlap, and that would be our solution in an exam. We'd get rid of the other two sections that aren't overlapping. So here's one that involves a parabola. So y is greater than or equal to x squared, and y is less than or equal to x plus 2. So the first one we know is a parabola, y equals x squared, and y equals x plus 2 we did before, that was the straight line. For the parabola, we can't substitute in 0, 0 because that is on the line. So we'll try a point that's inside the parabola, so 0, 1. And when I sub that in, 1 is greater than or equal to 0 squared, 1 is greater than or equal to 0, that is true. So therefore for the parabola, we are going to shade the part that has 0, 1 in it. So that's inside the parabola. Y is less than or equal to x plus 2, we sub in 0, 0. 0 is less than or equal to 0 plus 2. 0 is less than or equal to 2. That is true. So therefore we shade so that the line includes 0, 0. So there's our parabola with 0, 1 as inside the parabola being shaded because it was true. There's our line, y equals x plus 2. 0, 0, remember it was true, so we shade the part that includes. Once again, we can also find the point of intersection using simultaneous. We just, because they've both got y equals, we can just equate them to each other. So x squared equals x plus 2. To solve any quadratic, it must equal to 0. Factorise, you can use PSF if you want, and you get x minus 2x plus 1 in my two brackets. So that means x equals 2 or x equals minus 1. Substituting those two values, so x equals 2 back in, you get 4. Substituting x equals minus 1 back into one of the top two equations, you get 1. And there's our overlap with our shaded region. Thank you.